Okay, 48 brings us to a summation problem. And because we're only doing a sum from 1 to 6, we could probably handle this one directly by hand rather than using a new formula. But we're going to take a look at that formula as we go through this problem. So I'm going to allow I to start at 1. And I see this is the only place I'm inserting I. So I get 32 times 1/4 to the 1 minus 1, or 0th, plus my second term, 32 times 1/4 raised to the 2 minus 1, or first, plus 32 times another 1/4, this time raised to the 3 minus 1, and plus dot 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 until I get to 32 times 1/4 to the 6 minus 1, or fifth, giving us our 6 terms. And I see that my first term, 32 times 1/4 to the 0, would be 32 times just 1, or 32, plus 32 times 1/4, 8, plus 32 times 1/4, 8, times another 1/4, 2, plus dot, 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 until I get to 32 times 1/4 to the 5th. Okay, we could certainly write those terms out. We're going to get some fractions, add some fractions along the way. But I'm going to go ahead and take you to the formula for this, and we are looking for the sum of 6 terms. The first 6 terms from 1 through 6. The sum of the 6 terms of a geometric sequence would be equal to the first term, 32, times big parentheses, 1 minus our ratio. Well, our ratio is pretty clear. Each step we multiply by another 1/4. So our ratio is 1/4, and we raise that ratio to the 6th power. And that is all on just 1 minus the ratio, 1/4. And at this point, we could probably impress some 7th and 8th graders, but we're going to go ahead and just run this guy through our calculator, and we get S6 should end up being 42.65625. And that's our setup. If you need further information on this formula, it is attached on our website down in the notes section. It's also in your book.